Okay, so section 4.4, whoops. Here's question number 1. So they're giving me this graph, f of x, and in part A, they'll say, where is f of x greater than 0? Where's f of x greater than 0? So, so just looking at that function, where is that function greater than 0? F of x means y, doesn't it? Remember that? Remember function values are y values?
Between 0 and 2.
Yeah, right here, huh? Right there, and then out there also, right? Just simply looking at that graph, looking at that picture, and saying, hey, where's he positive? Where's he above the middle? Kind of like this is a roller coaster, right? It goes above, then it goes below, and then above, right? So where's it above the middle? Here and here. How do you say those sections? That's between 0 and 2. So we would say from 0 to 2, and then from 4 to infinity, huh? Because that arrow keeps going. United with 4 to infinity. Does that make sense for starters? So where is that graph? Where is it above the middle? It's above the middle. That's positive, between 0 and 2, or from 4 to infinity. That graph is up, isn't it? And if I had put a bar here, if I'd said where is it greater than or equal to 0, what would change in my answers? I would do the brackets instead, because bracket would mean right on. So right now I'm not putting it like for example at the 2 there's no bar here. So then like at 2 it's right on 0, isn't it? So I don't want to include 2, so I put a parenthesis because I just want it above 0, not where it's right on 0. Now in part B, let's go on to part B. They're going to say, tell me where the function is less than or equal to 0. So there they put the bar in. They want to know where is this graph, where is f of x less than or equal to 0. Yeah, this section and this section. So yeah, so that's negative infinity up to 0 bracket, huh? We never put a bracket on the infinities because you can never be right on infinity. United with, from 2 to 4, huh? So, whoops. 2 to 4. There we go. Everybody good with that? Makes sense so far? So that's pretty much what it's all about today, except in a few minutes, there's going to be no more pictures. We're going to have to do all those steps to get our own picture. So when you have the picture, though, it's pretty obvious, right? Where's the function above 0? Between 0 and 2 and 4 to infinity. Where's it less than or equal to 0? Negative infinity up to 0. Up to 0 from negative infinity to 0, and from 2 to 4. On that. And if you got the bar, you do the brackets on the numbers, never on the infinity. So there we go. So let's try doing part A. I want to draw that graph on your paper there, and we'll see if we can do part A. So part A over here is saying, where is that function less than 0? Where is that function below 0? So where is that function below 0? Right here. And then out here, huh? So those two sections. So how do you say those two sections?
So 1?
Yeah, looks like this is -1, huh? -1 right here.
But that's an asymptote.
Up to 0. Yeah, but we well, parenthesis, yeah, because you can't touch a vertical. -1 to 0. And then from here, looks like 1 to infinity.
Or 1 to infinity.
Yeah. Is that good so far? For where the graph is below 0. So the graph is below 0, between -1 and 0, and between +1 and infinity. The graph is below 0. So I'm always getting x values, huh? This is left edge, right edge, x values. left edge, right edge, x value. So those are intervals. They want interval answers. They want x's. That'd be like if you're a person walking back and forth on the x-axis and you want to know what x regions have a graph below. So in the x region between -1 and 0, the graph is below, and from 1 to infinity, the graph is below. Right? So it's always left edge, right edge, left edge, right edge for the intervals. All right, how about part B? In part B, they're saying where is the function greater than or equal to 0?
Negative infinity to -1.
Yeah, so it'd be this section
0 to 1.
and this section, huh? So yes, that would be, so where on the x-axis, can you write the intervals for that? Negative infinity to -1, very good. And this has the bar.
It can't have the bracket because it's an asymptote.
Yeah, not at the -1, huh?
It will never touch it.
It'll be at the 0.
But it will be at the 0, huh?
Yeah.
Like that. Everybody see that? Because that's left edge, right edge. Excuse me. Left edge. Excuse me again. Left edge, right edge there. And so from negative infinity up to -1, the graph is above. And from 0 to 1, including the 0, because it is a bar. So when you have the bar, when you have the, greater than or equal, you would like to have the bracket, right? Bar goes with bracket, B with B. Because when you're right on the money 0, like at 0, it's exactly at a height of 0. So we do have a bracket there. Why do I only have parentheses then at the -1 and the 1? Because those are vertical asymptotes, and you can never touch, you can never be right on a vertical asymptote, right? So those always get parentheses. Yeah. Not good? Good so far?
You can
Rachel?
go across a horizontal though, right?
You can cross, you can touch and cross horizontals, but never verticals. Because verticals denominator 0. It's not defined there. Good? All right. All right, so we're looking at that right there. So we want to be able to answer that question without a picture. Well, basically, you know how I'm going to do it? I'm going to get a picture. Basically what I'm going to do is graph that thing. So how do we go about graphing that thing? That's basically the game plan. How do we go about graphing the thing? Well, that's where the steps, let me real quickly write the steps up again. So for basically graphing x squared or fractions with a greater than, less than kind of stuff, what do? Step number 1. So I'll just write this up. Hopefully you've got it off the sideboard already. I'll keep it up there. Get 0 on one side. Make one fraction and factor everything. Step 2, numerator equal to 0. Denominator equal to 0. Numerator equal to 0. Those are always your x-intercepts. And denominator equals 0. Those are vertical asymptotes, huh? Wherever the denominator is 0. And then you go on to step 3, and you put, how did I say it, the answers? Yeah, put the answers on the graph and plug, that's kind of a bad plug in a number within each section. Within each section to find positive or negative, up or down. You're basically going to try to find out where's the graph above and where's the graph below. You're basically getting a quick graph is what you're doing. So I'll just leave it at that. That's basically the process. It's on the sideboard as well. So let's go back to it. So that's what we're going to do here. So we're going to take this one. So that means I'm just going to say, hey, just pretend there's a Y out there. That's okay to do. I'm just calling it Y, kind of like naming a pet or something. All right, this is Rover. This is Y. I'm just putting a Y out there, just giving it a name. And I'm going to basically answer this question. I'm going to find out where this function is less than 0 by graphing the function. I get a picture of it, then I can just look at the picture and find out where it's below 0. That'll be my answer. All right, so how do we go about graphing it? Well, step 1 says get a 0 and factor. That's done, huh? Step 1's already done. They're giving us a nice easy one. It's already got a 0. It's already factored. So I'll go on to step 2. Step 2 says set the numerator and the denominator equal to 0. Well, we don't have fractions yet. We will in a little bit. So we just take the only thing we do have, which is that, and set that equal to 0. That's all we have. We don't have a denominator or anything.
So we have 8 and
So notice what I'm doing though. Notice I just changed it from less than 0 to equal 0. I'm going to answer the original question less than 0, but the way I'm going to do it is I'm going to use the equal 0 to find out where it hits 0 right on, and that'll lead me to the graph, and then I'll look at the graph and find out really where it's below 0, which is their original question. Where is it less than 0? All right, so change to equal 0. So what numbers will make it equal? What can I plug in here to make that part 0? 8, and this guy -7, huh? So now step 3, you basically go to the graph. Put those on the graph. So I go to the graph, and I say, all right, at -7 and at +8, those are x-intercepts on the graph. Those are values that make the thing equal 0. Remember, there's a y out here. They make y equal to 0. They make the height 0, don't they? So is this making sense? So now I just need to find out, like, I don't know the rest of the picture. I'm going to find it out here in a second. Maybe it's up here, goes down there, comes up here. I don't know. I'm going to don't draw that. That's probably not it. But I'm going to find out in a minute. But my point is, it's only going to hit the x-axis there and there, nowhere else. Those are the only places, for sure we know that, those are the only places where the function is 0. Those are the only x's you could put in to make the function equal 0. So what? Well, that's actually really helpful then, because what that means is I can just check some number out here to the right, say like 9 or something. I could just plug in 9. And if I get a positive answer when I plug in 9, if the graph's up here, then it's got to be up there everywhere. It can't be up there for a while and then come back down, because it would have to cross, and I know it never crosses again. You know what I mean? So if it's up somewhere out there, then it's up everywhere out there, isn't it? And that goes for the other sections as well. What I mean is, I basically have 3 sections now. I have the left, the middle, and the right. And if I just check one point in each section, if it's positive there, then it's positive everywhere in that section. If it's negative at that point I plug in, then it's negative everywhere in that section, because again, it can't change its mind halfway through a section, because there's no more places it touches the x-axis, right? It's very helpful that I found the only 2 places it's going to cross the x-axis. So those are the only 2 places it can change its mind from being above to being below, or vice versa, is those 2 places. Nowhere else for sure. So therefore, that's what I'm saying back here in step, wherever it is, somewhere. Is that far back, really? Where did I write it? There it is. In step 3 is plug in a number within each section to find out if it's up or down, positive or negative. So that's what we're going to do. So because I don't really know if it's up here or where it is. So let me get rid of this. This was just all guesswork. So all I know right now is it hits at -7 and it hits at +8. So why don't I check 9. Now, how do I check? And then I'll check something in the middle, like how about 0? I always like to use 0 when I can. And then something over here like -8, just anything in the left. So 1 point in the left, 1 point in the middle, 1 point in the right, and just plug in to the function to find out what it is. So here we go. I'm going to plug in x equals 9. Plug in this value, which is a number in the right section. I could have used 10, 11, 12, 10 million. It doesn't matter. Any number to the right of 8. Any number in the right section. Where do I plug it in? Well, just plug it in to the function. This function right here. So, and find out what y equals. Y equals, so I'm going to plug into x minus 8 squared times x plus 7. Everybody see what I'm plugging into? So plug in the 9 there. And you're going to, yeah. And all we care about, to make this as easy and quick as possible, because it's going to take a long time, all you care about is the positive or negative. You don't really care what the number is. All we're trying to figure out is, hey, is it up, positive, or is the graph down, negative? At 9, is it above or below? Is it positive or negative? That's all I care about. So if I plug in 9 here, and I plug in 9 there, don't worry about the number. Just go, hey, positive, positive. It's positive. So that means at 9, the graph is positive, so it must be going up in this section. Is that good? The graph must be positive in the right section. It must be above the axis in the right section, because when I plugged in 9, I got a positive times a positive. I got a positive number. At over 9, it's up some positive amount. So that means the graph's up everywhere in that section because it can't cross again. So now let's go to the middle. So now in the middle section, I'm plugging in x equals 0. So plug in x equals 0 to the function. So y will equal 0 minus 8 squared times 0 plus 7. So 0 minus 8 is minus 8, but it's squared.
Oh,
Right? So minus 8 squared
is positive.
is positive times positive. It's positive. At 0, I'm getting some positive number. Is that making sense? So the graph's up here to the right, and in the middle it's also up there. See how I knew that? So when I plugged in 0, because of the squaring there, negative 8 squared is positive, huh? Positive times positive is positive. When I plugged in 8 plugged in 0 to that function right there, I plugged in 0 for x and 0 for x. Anything squared is always positive. Negative 8 squared is positive 64, right? Negative 8 times negative 8, positive, times positive 7. Positive, positive is positive. So it's way up there, positive. At 0, it's up positive. Now, I know it hits at 8. I found that out, right? It hits at 8 and hits at negative 7. I found that out because those are the values that make it y equals 0, don't they? So it has to hit at those 2 points, but to the right it's positive and the left is positive. It must have bounced right there. So I know it hits there, and I know it's positive on both sides, so it must have bounced there. See that? And now let's go over to the left section. So we got the middle and the right. Now let's go to the left. How about at negative 8? So I'm going to plug in negative 8 over here. Can I get this out of the way? So let's plug in x is negative 8. That's something left of negative 7, something in the left section. Plug into this function, so negative 8 there, negative 8 there. So you're going to get y equals negative 8, negative 8 minus 8. Squared is always positive. Negative 8 plus 7. So that's going to be positive times negative. That one's going to be negative. Did you all see that? Anything squared is always positive, isn't it? Right? So minus whatever, squared, that's going to be positive. Negative 8 plus 7 is negative 1, so that's negative. Positive times negative, it's negative. So that means when I checked negative 8, I got some negative value. So that means the function is down in that section, so the graph must go down in that section. So there's a rough graph. There's basically what the graph looks like on that. Ness?
So, you know how you got the x-intercepts, like, it was 8 and negative 7?
Right.
And on negative 8, it's squared, so it bounced.
Uh-huh.
Does that play a part, like the powers? Like,
Yes, I'm going to do that way too. That's a quicker way. I like what you're looking at. I'm going to do that in just a second as well, because that's even quicker, doing it that way. Exactly, that's what's going on. So far, so good. Does this make sense what we're doing? Let's answer the question now. After all that, we still haven't answered the question. We got the graph. What do they want from the graph? They want what section? The ones above or the ones below? What do they want? Look at the original question here. They're saying, please give me the stuff below. less than 0, right? The original question said, where's the function below 0?
Negative infinity to negative 7.
Here, and just there, huh? Yeah, nowhere else. That's the only section below. That's the only section. Now remember, you're trying to give the answer on the x-axis, like you're a little person walking back and forth on the x-axis. That'd be from negative infinity up to 7, wouldn't it?
Negative 7.
Oh, thank you. That's a negative 7. So the answer to the final answer is negative infinity to, well, let me write that a little neater. Negative infinity to negative 7. And it's parentheses on everything because we never had a bar, so there's no brackets. So there's the answer. Negative infinity to negative 7. That's the section on the x-axis from negative infinity to negative 7 in which the graph is below, the function is below 0.
So can you write the range for that?
What's that?
Range for that, like domain range.
Yeah, they're not asking for a domain range.
If they're asking how you can write it, I'm pointing like
The domain range is both infinities.
infinities.
Right, because it goes up forever, down forever, left forever, right forever. Good on that? Is that making sense? We good there? Questions I can answer on that? Now, I like what Naz was saying. Let me show you a quicker way. He was pointing out a way in which you could do this more quickly. Let me show you what he's saying. And I would suggest it. It's a good idea. So here's what's even quicker. And I didn't write it in my table. So what was the function again? X minus 8 squared, x plus 7. Okay. And we want to know where's it less than 0. Yeah, so here's a little bit quicker way. Right away, you find out from the graph, negative or positive 8 and negative 7. So over here, positive 8, negative 7, okay? And then, so you got those two x-intercepts. So you just got to find out left, middle, right, and above, below. Well, remember back in section 4.1, right after the exam, we had that section where we learned about whether a graph bounces or passes through, I think they called it crosses or touches, at various x-intercept points. And we also learned about end behavior. Now, that's the section I didn't lecture, and I ran out of time getting ready for the test, and I just said, look at YouTube. So it's kind of doubly helpful if I can also mention that again real quick, and it'll help us here on these problems, speed us up. End behavior. Remember how to find out the end behavior. Like in the end, way up to right, is this function going to go up, 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 or down, down, down? What's his destiny? What's his future? What's his end behavior going to do? Yeah, we'll get to that in a minute. That's not end behavior, though. How do we determine end behavior? Do you remember from that section?
Power.
Whether it's positive or negative.
Oh, do we put in the negative x?
So just think with me for a second. If your life depended on it, so no, be really serious. If somebody said, hey, here's this function. When you plug in 1,000, I mean, that's way over to the right, huh? That's the end. Are you going to get a positive answer or a negative answer?
You're going to have positive.
For sure positive, huh? For sure. Why? Well, I mean, you can just see if you put that into positive, that's positive. I guess that's one way. But another way is basically, if you were to FOIL this out, what end behavior is, if I was to FOIL this out, I don't want to do all the work, but I would get x squared minus 16x plus 64 here, and then I'd have to multiply the x plus 7, and then I'd come down here, and I would go boom, and anyway, whatever. I would get positive x cubed in the front, and then less powerful terms. Does everybody see that? I'd get positive x cubed, and then I don't really know what from there. Plus 7 minus something like minus 9x squared plus, I'm just going to make it up. I don't know what else it would be. Whatever, blah, blah, blah. It'd be something like that. Okay? So everybody see that the most powerful term would be positive x cubed. That's what will tell you the end behavior. The most powerful term is going to win in the end. When you're plugging in really, really big things to the right, like 1,000, a million, a billion, he's going to, if you plug 1,000 in here, and you plug it in the other x spots, the one, 1,000 cubed is so much bigger than 1,000 squared. It's 1,000 times bigger, huh? Because it's 1,000 times itself 3 times instead of just twice or once. So the most powerful term, his sign, will eventually control the function. make it go up for positive. If his sign's negative, it'll go down. So the in behavior really just means most powerful term when multiplied. So that'd be positive x cubed. So that function's going up. So you can really figure that out. I talked about it for a long time, but you can figure it out really quick. You can just look at that thing and go, look, most powerful x squared times x, positive x cubed. That's a plus sign there. Positive x cubed, it's going up. His end behavior is up. And then once you know that, you don't have to do all this kind of stuff to tell what the end behavior. Everybody see what I'm talking about there? You don't have to do all that stuff. The end behavior is just the most powerful term here times the most powerful term there. X squared times another x, positive x cubed. Boom, that quick, you know the most powerful term, you know the destiny of this function. Positive, up. If that was negative x cubed, it'd be going down, right? If I had something, well, I got to move on. So it's going up. Now, coming back to this point, it's going to hit here. Is it going to bounce or is it going to pass through?
Even number, power.
Yeah, that's all about not the end behavior, but the power, like Abdul said, just on that particular term, which means this term. What's his power? Even. Do you remember that from that section? Remember, think about y equals x squared, which has an even power. What does he do? He's a U-shape. So what does he do? He bounces. See how he bounces? Whereas if you have an odd power, like x cubed, what does that do? Remember, that's the snake. See how he passes through? That's because even power, it's positive on both sides, right? You know what I mean? If you go over to like positive 3 or negative 3, either way it comes up to positive 9 when you square it, doesn't it? So even powers bounce the thing, don't they? You see that? Even powers are always going to bounce it. Odd powers are going to let it pass through because they change signs. If you plug in negative 3, you'd get negative 27. Positive 3, you'd get positive 27. It would change signs. For odd power, your signs change. It passes through. But for even power, it bounces. Okay. So now that's just on that term. So looking back here, I'm looking at the 8, just the 8, and I'm saying, what's it going to do at just the 8? Is it going to bounce or pass through? So you go back and you look at just this guy, not the whole thing. I'm not looking here anymore. I'm done with that. That multiply it out in behavior, done. Don't look at that power. That's just the overall result. Now I'm saying just this guy. What's he? He's a 2 power. That's an even power. So he's going to bounce. Boing, which we did find out. And then how about this other one? What's his power? Just him. His power, invisible 1. It's odd. It's going to pass through. You can have it that quick, which is the graph we eventually got through plugging in. So you don't have to plug in, at least for these kind. You don't have to plug in. You can just do in behavior, bounce, pass through. Next.
You don't have to find the middle. You don't have to find 0.
You don't have to plug in anything.
If it's squared or if it's an even power, then it's always going to be positive, and then the
So
second.
I can't simplify it any more than this. So in other words, the in behavior is positive, it's up. If the in is negative, it's down, and then just trace it back. Even powers bounce, odd powers pass through on those individual terms. All right, we better move on. Let's try. All right, so why don't you try that one? So this time you do have to do step number 1. Remember what step number 1 is?
Get a 0.
Got to get a 0, yeah. So this time that is required. So get a 0 and factor. So bring this over to the other side. Get 3x cubed plus 15x squared. Like that. And then factor that. So I'll let you take it from there. So go ahead and factor that. Okay, so we got a factor.
You can take out 3x squared.
Yeah, good with the factoring. Take out the greatest common factor. 3x squared. Is that good like that? Remember that? All right, take out what's in common. So there's step 1. Step 2, find out what makes solve, what makes it equal 0, right? So now you take the function And for just a moment, you change it to equal 0. Because basically we want to graph it now. Basically the rest of this problem is getting a quick, rough graph. So go ahead and find out what makes it equal 0 and then put that on the graph. So, okay, this first part, what makes that part equal 0?
0.
Just 0 itself, huh? Just x is 0. And then this part, what makes him equal 0? And by the way, look at the powers on them. This guy has an even, so that point's going to be a bouncer. And this part has a 1 power. He's going to be a pass-through when you go to the graph, you know. You want to just put that on right away. Go to the graph and we say, okay, -5. And you can just put pass-through. And 0, and you can put bounce. See how I know that right away? Based on the power that's on that individual term. Anytime it's even that's going to be a bounce. Odd, that's going to be a pass-through. Did you catch that from that 4.1? Or maybe it's been a couple weeks and you've forgotten. So good little review here. Is that good? You remember that, how that works? And so now, basically we've got the graph almost. Now we can just find the end behavior. You know, find if it's above or below. Then we can just trace it back.
It's going to be x squared.
Yeah, so how do you do the end behavior again? You multiply it out and take the highest.
Well, it was multiplied.
Yeah, really, you could just go like that, huh? That's how it started. Totally. So the highest power is certainly 3 positive. 3x, so it's positive, it's up. In the end, it's got to go up. Yeah, exactly. It started multiplied out. That's right. So you could just grab that. If you didn't notice that, it's okay. If you just multiplied this times this, you'd get that same thing, right? 3x squared times x, you'd get positive 3x cubed. See how multiplying it out. So, and why are we multiplying it out? Because when you multiply it out, then you can see what's really most, you know, when it's all factored, it's separated, it's hard to tell. But when you multiply it out, you get the most powerful, second most powerful, etc. You find out who's going to win in the end, positive, up. Rebecca, do you have a question?
No, you can answer that.
Yes, sir. Okay. So we know that's up. And then we just kind of trace it back. And we go bounce. Right? We already learned that's going to bounce. It's a lot like the last one, huh? It's going to pass through there. There's a rough graph. Is that good? Does that make everybody see how I got the bounce pass through stuff? Just when you get the 0 thing, just look at the power on him. If it's odd, that's a pass through. If it's even, that's a bounce. You just put that right on the graph. Like that. Okay, now having done all that, we're ready to answer the question. What is their question? They're saying, tell me where this function, and by the way, don't go back to the beginning. Once we get the factored version with 0, like the end of step 1, you know, step 1's all about getting a 0 and factoring. Once you're done with that, never go back. It's just going to be easiest to work with that. It's the same thing. It's the equivalent question. The answer to the original is the same. They're this and these guys are the same question. But this one's way easier to work with. So they're saying, where is the thing greater than 0? Where is it above 0? Here?
Oh, yeah.
And here.
Uh-huh.
So we say -5 to 0. And there's no bar here. If it said greater than or equal, I'd put brackets. United with 0 to infinity, right? Out to infinity.
Right.
There we go. This making sense? Questions I can answer? Real good. So we're getting a rough graph. We're quickly getting a rough graph is what we're doing. We're answering the question by graphing.
I hate graphing.
Yeah.
So for the solution,
I'm so
I was looking also like at the answers range.
Can we do like doing that?
And it seems like you're highlighting above the minimum, right, above 0 for -5 to 0 and then 0 to positive infinity.
Right.
Is that what we're just trying to find the positives, right? Nothing else?
Right, because they said greater than 0.
Okay.
Yeah, so greater than 0 means positive. Yeah. Now sometimes they'll say less than 0, and then we'll want the negatives. Then I would want this section.
Yeah, because I was grabbing it, I just wanted to know what.
Yeah, so it's going to be one or the other. If they say greater than 0, you want the positives. They say less than 0, you want the negatives. Yeah, it'll always be one way or the other. Good? Other questions on that one? So I'm making sense?
Yeah, grading.
Everybody see Tristan, right? Tristan's question? Tristan? Right. Did everybody see that? That's a good question. Everybody with that? Why did I take the positives? Because they said greater than 0. Sometimes I'll say less than 0. And I'll give them the negative. All right. Okay, so try that one. How are you going to recognize these on the next exam? This whole thing, it's what's the unique mark? It's the greater than, less than, right? There'll be 2 of these on the next exam in 2 weeks. One will be regular like this, one will be a fraction. Just straight ahead like that. There'll be one that's normal, one that's a fraction. Greater than, less than. Try that one.
I don't like this.
So step 1. So get a 0 and factor. So bring this over. Like that, and then factor. So again, yeah, that's a double. I call it x squared times x squared. 16 times 16. You square root the 256, it's 16 times 16. So that means it's x squared plus 16. X squared minus 16.
That can be broken down even better.
Yeah, and then do one more step of factoring, huh?
X plus 4, x minus 4.
So go ahead and do one more step. I'll let you finish from there.
I was thinking of like
I can go for it.
So can we do we can do one more step, right?
Mm-hmm.
But do you remember that you can't do the plus? I mean he'll still be there, but he doesn't break down any further.
He doesn't.
Whereas this one does.
Mm-hmm.
This one becomes x plus 4, x minus 4. That's really important. Do you remember that? It comes up a lot. It'll just always trouble you if you're not aware of it. Do y'all know what I mean? Do y'all see what I'm saying there? It's really important. It comes a lot. I call it double-double. The double-double plus can't be factored further. Right? And you might think, it looks like it should be x plus 4, doesn't it? But it's just not. If you could test it, if you FOILed it out, you would find out there's an 8x in the middle. It really isn't x squared plus 16. It's not right. So be aware of that the double-double plus can't be done, but the double-double minus, you can do that one always. So we get to this. So that's as factored as we can get it. That's as good as it gets, right? Because again, the double-double plus cannot go further, and these guys are just x to the first power, so they're done. So we're done there. So now we can go to the graph. It's all factored. So we were done with step 1. Now that we have step 1, we're never going back to work with anything else. This will be the easiest version to work with this point forward. So just keep working with that. Step 2 now is define what makes the various parts 0. So what can I plug in here to make this guy 0? Nothing. Good. Are y'all aware that there's nothing that can make that part 0? Right? Anything you plug in, squared is going to be positive. And then add 16, it's going to be, bigger than 16. It's not going to be 0. So, and then this part, what makes that part 0? Negative 4. Hey, what's the power on him? 1. He's going to be a pass-through. What makes that part 0? Positive 4. What's the power on him? 1. Pass-through. So we just have those 2. We're ready to go to the graph. That's step 3 is basically graph. So if we go to the graph, we're going to find at positive 4 and at negative 4, those are both pass-through points. Like that. And now, let me let you find the end behavior. What's it going to do? Way out here, his destiny in the end. What is he going to do? Yeah, because it was right there in the beginning. Again, you can multiply it out if you wanted. X squared times x times x. You're going to get positive x to the 4th as the most powerful term when multiplied out. Y'all tracking with how I'm doing that end behavior? That tells you what that function will do in the end, whether it'll go up or down. Right? If you multiply this out, what you get, if it's positive, so this function's going up in the end, like that. It'll pass through. Then you can just kind of trace it right back through. It's going up in the end. We know that because this is positive. If this end behavior term was negative, it would go down. So it's all about the sign on the most powerful term. That's what will determine whether it goes up or down in the end behavior. So anyway, then it passes through. It's got to hit here, passes through. It's just a big U. This graph is just a big old U. Because it's got to pass through both those points. Question? So now we're going to answer, where is the function greater than 0?
-4. Or
Oh,
negative
yeah.
infinity.
Yeah, this section and this section. So that's from negative infinity to -4, union 4 to infinity. All that work for that answer. There it is. Does that make sense? That's where the function is greater than 0, right? Because at the very end, they're always going to ask us greater than 0 or less than 0. At least we're making step 1 always have a 0, aren't we? So that we can get it down to greater than 0 above. If that had said less than 0, then they would have wanted where it's below 0. It would have been from -4 to +4. That would have been the section below 0, right? They could have done that. But they didn't. We good? Questions? Yeah, Tristan?
So like I noticed -4 and +4 for like both those parentheses that you broke down, but what do I do with x squared plus 16? Doesn't that have like its own marker?
No. So there's nothing? There's nothing you could, he never makes an x-intercept. There's nothing you could plug in for x here, square it, it'll be positive, add 16, it'll never be 0. So he doesn't make any hit 0 points at all. Now, he never makes an x-intercept. Basically, this is the graph. This is the rough, general graph right there.
How did you determine that was positive?
Which was this?
-4.
Well, I started here,
Okay.
and I just got that by tracing back. So I said, this is positive because it's the end behavior is positive.
Okay.
And then it had to pass through, and it didn't bounce. It had to pass through, so where can it go? It's got to go up.
Okay.
Right? So when it passes through, that means it's going to the other side.
Right.
Wasn't there an old song like that? Pass on through to the other side of some line.
No, that was the Doors.
Okay, was it? All right, anyway, whatever. If that helps you remember, right? When it passes through, it's got to go to the other side, so it had to go up. Abdul.
This one is going to be x4 to minus 254. So in this case, we should like get like a fourth root.
There's other ways. I think
Right?
this way was fine.
No, yeah. This one is going to not 256. It's going to be 257 or 253.
Oh, what would you
Yeah,
do in that
like
case?
A fourth root.
Yeah, it'd be a lot harder. Yeah, maybe, yeah, I'd have to see the problem. I don't know. It would
So for
depend.
example, x4 minus 31. So we can write it 31 root 4.
Yeah, you could do something like that. Yeah. All right. Number 14, yeah. Okay. So number 14. So now we're diving into fractions. So same kind of thing. Got the greater than, less than, fractions. So like I told you on the exam we take in 2 weeks, there'll be one fraction one not fraction one with a greater than, less than. So all right. What are we gonna do?
Equals
Set it to 0.
Yeah, the steps say get a 0, make it one fraction, blah, blah, blah. I'm going to do it wrong. And so don't write this down. But watch me do it wrong. It's important because it's really easy mistake to make. Really easy mistake. Let me give you a hint ahead of time to see if you can pick it up. Because no one ever does, because it's a very, very subtle mistake. If I do it, it'll look great. It does. It looks great. And it's completely wrong because it's a really subtle mistake. So let me give you a hint about what mistake I'm about to make. Think about, remember when you solve greater than, less than. It's because it's greater than, less than, not equals. That's the whole issue. The whole issue is greater than, less than. What special rule do you remember about greater than, less than? Think about this. What if you had minus 2x less than 10 or whatever, and you wanted to solve that? Remember that from your algebra days? Yeah. What do you got to do to solve?
Sign flips.
Divide by minus 2, and the sign flips. Remember that? That's the issue, right? When does the sign flip? When you multiply or divide by a negative, you must flip the symbol. You know that rule, right, from algebra. Why? because that's just what's true. You can just prove it with numbers. Like take 10's less than 20. That's certainly true, right? If I was to multiply both sides by, I don't know, whatever, -3, and not flip the symbol, I'd get -30 is now lower than -60. That's not true. Here's 0, here's -30, here's -60. Who's lower? -60. See, if you don't flip the symbol, you lose the truth. When you multiply or divide both sides by a negative number. It's just simply what's true. Right? So, when you multiply or divide by a negative number, you've got to flip the symbol, right? What if I have an equation like 2x greater than 10? How am I going to solve that one?
Subtract 10 on both sides.
Divide by 2 on both sides,
Oh, I guess you could do
right?
that.
And do I flip the symbol? What if I flip the symbol? Would that be okay? No, I must not flip the symbol. In that case, I must not, because I divided by a positive number. So if you divide or multiply by a positive number, you must not, emphatically not, flip the symbol, or you'll lose the truth. Right? If you multiply or divide by a negative, you must flip the symbol. So let me ask this. What if I had x over -2 greater than 5? How would I solve that? How do you get that x alone? Multiply both sides by -2. That cancel that out. And
And it flips.
you got to flip the symbol because you multiplied by a negative, and that'd be your answer, and that's correct. Okay. What if? Let me switch it now. What if I had 10 over x less than, I don't know, whatever, 20? What's the denominator now? X. So what am I going to multiply both sides by? X. Right? Cancel out. And get 10 less. Oh, hold on. Before I go on, should I flip the symbol there or should I not?
We don't know because we don't know what x is.
Good. You don't know what x is.
Could be a negative.
It could be positive, could be negative. It's a variable. You with me? So at this point, you need to think more maturely, mathematically maturely, about x. You don't want to just look at x and say, well, he's positive. No. There's no negative sign in front. No. He's a variable. Remember? He's a variable. He could be negative. He could be positive. Point is, I don't know. I don't know whether he's positive. I don't know whether he's negative. I don't know what he is. He's a variable. So should I flip the symbol or not? I don't know. So I better not do that move. Do you see why that's not a good move? You shouldn't multiply both sides by x because you don't know whether to turn the symbol or not. Because you don't know whether x is positive or negative. If x is positive, you must not, emphatically not turn the symbol. If x happens to be negative, you must, emphatically must turn the symbol. And I don't know.
Plus or minus?
I don't know what x is. So you're catching the point. You never want to multiply with a greater than, less than problem by x because you don't know whether to turn the symbol or not. You don't know if x is positive or negative. Well, okay, how about if instead of x, how about if it was something like x plus, I'm trying to erase that there, x plus 3. How about if it's x plus 3 instead of x? Could I just multiply both sides by x plus 3? Because by the way, if this was equals, that's totally what I would do. Right? That's right on. I mean, that's just exactly what you would do. If this said equals, you would multiply both sides by x, so cancel it out there, you know, and
You still don't know.
get 10 equal, on we go. But if it's less than or equal, then if you have a greater than less than, then you need to know whether to turn that symbol or not. And do I know what x plus 3 is? No again, because I don't know what x is. If x happens to be -7, then x plus 3 is -7 plus 3, it's -4. It's a negative number, and I better flip that symbol. But if x is something like, 0, then 0 plus 3 is positive 3. I better not flip the symbol. The point is, I don't know. So you can't multiply by anything with an x in it. Can you? You cannot multiply by anything with an x in it because you wouldn't know whether to flip the symbol or not because a variable, you don't know what it is. So all of that is to say, here's what I see on tests a fair bit. People come in and they'll go, oh, just multiply both sides by x plus 2. And that's an excellent step if this set equals. If that set equals, that's exactly what you want to do. It would cancel out the left side, boom, boom, and away we go, we get an answer. But not with greater than, less than. I don't remember what it was less than or equal. Not with less than or equal, because you don't know what x is and you don't know whether to flip the symbol or not. Does that make sense? So that's all that I wanted to say about that. There's no multiplying by anything with an x. So let me write that. So don't do that. You guys aren't going to do that on the test, right?
Hopefully
You
not.
promise me you will not do that on the test, right? Never multiply both sides
By X.
by anything having x for greater than, less than, I should say. For equals, it's great. For equals, that's perfect. That's exactly what you would do. But for greater than, less than, never multiply both sides by anything having x, because you do not know if it's positive or negative, so you can't decide. It's a lot of words here. Whether to flip the sign or not. So that's the deal. So you cannot multiply both sides by anything having an x with a greater than, less than problem. Can't do it. You don't know whether to flip the symbol or not. All right, so that's a long story about what not to do. So what do we do? That's why I give you that whole process. Because we can't do that, we have to do something kind of difficult. Step 1, get a 0. So bring this over. So it becomes 3x minus 2 over x plus 2 minus 2 less than or equal to 0. We good there? Let me get a little more room here. Kind of squishing it in. Good to there. Step 1, get a 0. And then what else did I say? Make the other side one fraction. Get a 0. Make it one fraction. So I can't leave these separate. I got to make these into one fraction. So that means I come in here, put this over 1, make it look like a fraction. And what do I do to make them one fraction? Multiply top and bottom by x plus 2. Right? Then they're going to have the same denominator. Is that making sense? So now, what do I have? I have 3x minus 2 times x plus 2. Or you could just, let's just save a step. Let's distribute it right there, huh? Yeah. So we get minus 2x. Watch out, minus 4. Did y'all see that? That's a really, really common mistake. People forget that negative is on the 2 wherever he may travel. So when he goes to negative 2 times plus 2, it's minus 4.
So why don't we just combine like terms and...
So now we will, yeah, combine like terms. That's exactly right. 3x minus 2x is 1x. Minus 2 minus 4 is minus 6.
Over x plus 2.
Over x plus 2 less than or equal to 0.
Okay.
So that's step 1. All of that is step 1. We got a 0, and we made the other side one fraction. So this is what we're going to use from this point forward in the problem. It's just easier to work with this. Basically, we're going to graph that now. We want to get a rough graph of that thing, find out where the graph's above and where it's below, and they want us to give them the parts that are less than 0. So this time we're giving them below 0. So Tristan, this is a below 0 one, right? This one they're going to want below 0 in the end. Once we get the graph. Good so far? It's making sense? Anything I can say to help? Is that all good?
Sure, it'll make more sense once I break up.
All right, let's keep going. So what's step 2? Numerator 0, denominator 0. So I'm going to take it to the next page, if you're okay with that page. So continuing number 14. X minus 6 where x plus 2 less than or equal to 0. Okay. So the numerator is 0. So now we take step 2. So the numerator equal to 0. So x minus 6 is 0. Jump it over. X is 6. The denom is 0. So you grab the denom.
It's -2.
X plus 2 is 0. So x is -2. So then we go, step 3 is we go to the graph. Oh, and by the way, denominator 0, this is going to be a vertical, isn't it? Vertical asymptote. Remember, whatever makes the denominator 0 is a vertical.
Right.
And whatever makes the top 0 is an x-intercept, isn't it?
Yeah.
So when I go to the graph now, at -2, -1, -2, we're going to have a vertical asymptote. And at +6, I'm going to have an x-intercept.
Just 0, 6.
6, 0.
Yeah, 6, 0. Or y is 0. That's what an intercept is.
We good to there? It's making sense so far. This breaks the graph into 3 sections, doesn't it? Left, middle, and right. And so now I basically just have to determine, is the graph above or below 0 in the right? Is it above or below 0 in the middle? Is it above or below 0 in the left? Got to get a rough graph. How do I figure that out? Well, this is where I'm going to suggest, normally how we do the end behavior and the bounce and the pass-through, that's just hard to do when you've got vertical asymptotes, when you got fractions, because you don't touch a vertical. Remember, it doesn't touch the vertical. So at the vertical asymptote, it's neither going to bounce nor pass through. It's not going to touch it. So I would suggest when you have vertical asymptotes, here's my suggestion. For vertical asymptotes, just plug in a number in each section and to find out if it's positive or negative. Rather than bounce, pass through, in behavior stuff, just plug in a number. It just gets too tough with the vertical asymptotes.
Can you just say fractions? Or
Yeah, for fractions, exactly. So vertical asymptote fractions. Yeah, well said. Well said, Ness. Yeah, for any fractions, just plug in numbers in each section. Exactly.
Because all fractions.
Because all fractions end up having verticals. Exactly. Yep. So anytime they give you one of these fraction problems, I would just plug a number into each section rather than try the whole in behavior bounce pass through.
Plug a number from
So each section
into the top, and each number one.
We'll see. So what's a number in the right section?
7.
How about 7? You could use 8 or 9 or 10 or 10 million. Anything in the right section? What's a number in the middle section?
0.
0's nice. You could use -1 or 1, 2, 3, 4, 5. Anything in the middle? Something in the left?
-3.
Like -3. So I'm going to plug those numbers in. Now what are we going to plug into? The version where we had the end of step 1, right? Where we had the 0. Remember, that's y equals. We're graphing y equals that. So I'm going to plug in x equals 7 to what? To this. Y equals 7 minus 6 over 7 plus 2. See what I'm plugging into?
1/9.
Everybody see what I'm plugging into there? I'm plugging into the function we had at the end of step 1, where we had the 0. Now, to make this, again, as quick as possible, you don't care about what the number is. All we care about is it positive or is it negative? Is it above or is it below?
Positive.
So what is it? It's positive over positive, isn't it? Right? That's positive, that's positive. So that means it's up here. Isn't it? Here, let me draw it a different color. It's up
And it's
here.
not going to bounce, it's just going to pass through, right?
I don't know. I'm just going to check each section. So now I'm going to go to the middle. And I'm just going to plug in a number in the middle.
0.
So I'm going to plug in 0. So let me get this stuff all out of the way here. So yeah, I'm just going to plug in 0. Which is a number in the middle section to this function. So y equals 0 minus 6 over 0 plus 2. Y equals negative over positive. Remember, who cares about the numbers? Just find out if it's negative or positive. So y equals negative over positive. What's negative over positive? Negative. So that function must be down here. Right? It's got to be negative. Does that make sense? And we know in a vertical, you either go down to infinity or up to positive infinity, right? So this one must go down to negative infinity because it's down here in this section. Is that good? Now, over in the left section, I'm going to plug in negative 3. So let's do that. To the same function. Y equals minus 3 minus 6 minus 3 plus 2. Again, we don't care what the numbers are. It's just the top is negative, the bottom is negative, negative over negative.
Positive.
Positive. So that means what? That means the function is positive in the left section, which means it's going up, and I don't know, somehow it's staying up here positive.
It doesn't suggest.
There we go. We've got a quick, rough graph. Now making sense?
How are we supposed to know what it does into the upper quadrant? How are we supposed to know?
What it does where?
You're talking about the curves, right?
Yeah.
Yeah, I was wondering that too.
How it does where?
How it
Right
curves,
there.
like,
Right
yeah,
here?
Yeah.
Yeah.
Well,
'Cause
we don't.
We know it goes up.
Let me say two things.
Okay.
First off, we don't care. I mean, I'll show you how to do it. You actually already have the skills. It's the horizontal asymptote.
Yeah.
But really, I don't care. So I don't want to
Never touch
complex
that.
it with more. There's plenty we have to work on here. So I don't want to confuse everybody in general. I don't care. I know it's positive everywhere there. And that's all I care about.
All right.
Right? You know what I mean? It can't cross.
Right.
There's no more x-intercepts. No way that thing's crossing. So if it's positive somewhere
It's
out
gonna
there, then it's positive everywhere out
Okay.
there.
But it'll
It's
go
got
up
to.
by that. It will be positive up by the asymptote.
Oh, and in asymptotes, it always goes up or
Yeah.
down forever, as we talked about.
Okay.
It's got to do that.
But if it's positive, it's going to go up by the asymptote.
Right. And if it's negative, it's going to go down
Okay.
by the asymptote. Yeah, got to be. But as far as what it actually does, way off to the left, if you're interested, horizontal asymptote. Remember?
Yeah.
Positive, it's positive 1. See, most powerful term in the top. Remember we learned about horizontal, you just did that homework last night, right? What's the horizontal asymptote? X over X. Remember most powerful term in the top, most powerful term in the bottom? The horizontal asymptote is X over X, positive 1. That means there's a positive 1. So really, this isn't going to rocket up. It's going to approach up. And this guy's going to level up. But anyway, we don't need to worry about all that right now. That's what it's going to do, though. We do have that knowledge. Is that good on that? So now, what's the answer to this question after all that? Like, what is the answer to this question? What do they want? Which section do they want?
They want the one less than or
Less than or equal to 0.
Less than 0. Where is the graph less than 0?
Only
Right there. Between what? Negative 2 and 6. Between negative 2 and 6. Oh, and bracket it to 6, huh? Because it wants less than or equal. You want the bar. So we bracket the 6, but we have to put parenthesis at the negative 2 because you cannot touch negative 2. So there is the answer to the question after all that work getting the graph. Ness.
I don't know if you want to get into it, but how you said, like, it intersects the 6, and then we found out the horizontal, the asymptote is 1. It doesn't cross that, right?
Doesn't cross the horizontal asymptote?
It could.
It can. No, it can. Yeah, so honestly, I don't want to get into it. Coming off stairs, be glad to show you more details. Calculus, you get more into when they do that and how they do it, and I can talk to you about it. Good there? Is that making sense? Let me recap again real quick. So what did we do? So these are hard ones. So what you got to do when you get these is you got to get a 0 on one side, make the other side into one fraction by common denominator stuff. Make it one fraction. Then once you've got that one fraction 0, you never go back. Use that thing from there forward. And so what did I do with that thing then? I just found out what made the top 0 and what made the bottom 0. Top 0 was the x-intercept at 6. Bottom 0 was a vertical asymptote. And then I just plugged in a number in each section to find out if it was positive or negative, above or below in each section. I found out the right section was above, the middle section was negative below, the left section was positive above. And then in the end, I say, what do you guys want? Well, we want the things negative, the things below 0, please. So that was the middle between -2 and 6. Bracket at the 6, because you can be right on the 6. They have the bar. We have the bracket at 6. But -2 must have a parenthesis because it's a vertical and you can't touch a vertical. How you doing? Questions? Other questions on that? We good? All right. Try that one. Why can't we just do this one by multiplying both sides by x minus 6?
I wrote a Java program that calculates a certain degree of slowness.
Right. Is everybody good with that? Why can't I just multiply both sides by x minus 6?
I'm just going to put it through my...
Because it has an x, and I wouldn't know whether to turn the symbol or not.
I just got my substitution numbering backwards.
Okay, so bring that one over. So step 1, get a 0, factor. So x plus 17 over x minus 6 minus 1 greater than or equal to 0. So step 1, get a 0, and then you got to make those into one fraction. Yeah, I shouldn't say factor. It's one fraction, huh? Yeah, get a 0 and make it one fraction. So we got to make those one fraction. Let me get a little more room here. Minus 1. So how do we make those one fraction? You put 1 over 1, then you multiply
X minus 6.
top and bottom x minus 6, right? We good?
That's -1 times x and -1
Good.
times -6.
The way I've written it is really bad. That minus sign,
23.
remember he's on there. Watch out for that. X plus 17 minus x plus 6. Everybody good there? It's really easy to forget about that minus sign, right? Going all the way to the minus 6. Everybody see that step? And so then the x's drop out, and 17 and 6 is 23. We get to there. No x's on the bottom. So there's step 1. Get a 0, make it one fraction. So now I'll come over here for step 2. Step 2, we're supposed to do numerator equal to 0. How do you have the numerator equal to 0? No way. There's no x there. So there's nothing out of the top making the numerator 0. And then denom equals 0. So that'd be the x minus 6. And so that's just 6, huh? And what's that? That's going to be a vertical asymptote. So that means all we have on this graph is a vertical. When I go to make the graph, at 6, there's going to be a vertical and nothing else. This graph will never touch the x-axis. Do you realize that? It just has a vertical at x equals 6, and you never touch a vertical. It doesn't have any x-intercepts. There were no answers out of the numerator, which is where our x-intercepts come from. There was nothing. So this graph will never touch the x-axis. It'll just have a vertical at 6. Good so far? All right, so let's go. I'm going to go to step 3 and basically get that graph. So step 3, which is the graph step. So what is our equation? 23 over x minus 6. 23 over x minus 6. Y equals, and we're doing greater than or equal to 0. Okay, so the graph at 6, we have the vertical. Okay, so basically we only have 2 sections, don't we? Left of the 6 and right of the 6. 2 sections. That's it. So check over here, plug in like 7. And over here, how about 0? You can do 5, 4, 3, 2, 1, negative, 10 million, whatever. But I'm just going to do 0 and 7. Left of the 6 and right of the 6. Just making sense? You're just checking each section to see whether the graph is above or below, positive or negative. So plug in x is 7. And then where do you plug it in? Right here to this function. Y equals, what are we going to get? 23 over 7 minus 6, which is positive, isn't it?
Yeah.
All I care is positive or negative. Just save time. You don't care about the number. So what does that mean? That means the graph, now what is positive? It's doing something like this. It's going up to infinity. Remember, at a vertical, you're always going up or down to infinity. If it's positive, it must be going up to infinity. Do you want me to say that sentence again? At a vertical, you're either going up to infinity or down to negative infinity. Since the graph is positive in this section, it must be going up to positive infinity. I don't know what it's doing off to the right. Oh, actually, I do. What's the horizontal asymptote?
0.
0. Remember how to do the horizontal asymptote of this thing? Highest power in the top, highest power in the bottom, just 23 over x. Plug in infinity, 23 over infinity. If I had 23 10 millionths of the pi, I had no pi.
0.
That's 0. So it's coming, there's actually a horizontal asymptote. You know, we don't need to know all that, but I'm kind of reinforcing what we learned earlier. It is coming down to a 0 horizontal asymptote. Anyway, so now how about the left section? Is it going to be above or below in the left? Well, let's plug in 0. Plug in x equals 0, which is a point in the left section. So what do you get?
0.
Y equals 23 over 0 minus 6, which is negative, isn't it? Positive over negative, negative, which means the graph must be going down to negative infinity at the vertical, because you always go up or down. If it's negative, it's down. And then we already know it's leveling off at 0, horizontal asymptote. But it's down everywhere, up everywhere. And what do they want? Which section do they want? Above or below sections?
Greater than or equal to.
Greater. They want the part greater. They want this section. So where is that?
From
6 to infinity.
Did you have to put
From 6. Yeah, no brackets because 6 is a vertical.
Okay.
You can't touch it because normally, yeah, the bar would normally mean we want a bracket, huh? But you can never touch a vertical asymptote. So we have to put a parenthesis on the 6 because you can't really touch it. We good? Because I got a harder one. Good there? Okay, so what do we got to do?
Get a 0.
Get a 0 on one side, bring that fraction over, get a common denominator, and make them into one fraction. Yeah, it's a review of all that stuff from algebra. Hard stuff, difficult. One of the hardest things from algebra is common denominators, add, subtracting fractions. See what you remember.
Does the subtract, when you subtract,
Sure.
it doesn't go, yeah, never mind.
So I'm going to, yeah, I would probably just jump it over. Same thing. So it's 3 over x minus 9 minus 7 over 9x minus 1. I really just subtracted that fraction. Is that confusing? I just subtracted 7 over 9x minus 1 from both sides. I just didn't want to write all that. I just subtracted from both sides the fraction to get a 0. Is that good? So step 1 now, you have to combine those and get a common denominator.
I need some worksheets.
Good. Practicing all these.
I don't like this.
Okay, so common denominator, right? How do you get common denominator here?
Multiplying by each other.
Right, by the other denominator, huh? Remember that from algebra? So 9x minus 1, top and bottom of that guy, and then x minus 9, top and bottom of that guy. That way they have the same two things in the denominator now. They're common denominator. You with me? Did you see what I did there? So now these guys have the same denominator, the same two things in their denominator. See that? So now you got to multiply out the tops. Boom, boom. 27x minus 3. And then this, careful, that minus is really on the 7. I would suggest it would be easier for you just to move that up there and put that minus right on that 7 so that when you distribute it, you don't forget about it. That's like the number one most common algebra. That's probably, if I make top 10 lists, that's number one algebra mistake in an algebra class. That's the easiest thing to forget because that minus is way back there. Everybody see that? So it's going to become minus 7x plus 63. That minus is on the 7. It's his minus sign wherever he may go. It's his baby. Takes him with him. We good? Everybody see that? So then just combine terms there. We're going to get 27x minus 7. So it's a 20x plus 60. Oh, it's getting a little sloppy. Let me bring it over here. So 20x plus 60
over.
x minus 9, 9x minus 1, less than 0. So that's all step 1. That's the end of step 1.
Wait, where is it? Oh,
Plus you didn't. Oh,
Okay, that good? Now, you could factor the top. You don't have to. Doesn't really matter. So I'm going to go on to step 2. What do we do step 2? Numerator equals 0. So take the top and set it equal to 0 and solve. Move the 60 over.
negative
20x
3.
is minus 60 divided by 20. X is minus 3.
Yeah.
So that's going to be an x-intercept, isn't it? Because it came from the numerator. Whatever makes the top of a fraction 0 makes the whole function 0. It's a height of 0. It's an x-intercept. And then, kind of running out of room here. Now denominator
Oh, it's already factored.
equals 0. So for the denominator, the x minus 9 piece, that's easy, x is just 9. The other piece, 9x minus 1 is 0. Move the 1 over, 9x is 1 divided by 9. X is 1. So 9 and 1/9, those are both going to be verticals. And negative 3 will be an x-intercept. I think this is like the hardest problem in the section, probably.
Oh, wow.
So now you can go to the graph. Now you can go step 3 to the graph.
Oh, negative 3. No.
Can you do that? So go step 3, go to the graph. So I'll go to the graph. Is that too quick? Everybody seeing all this stuff? Is this all okay? All right, I better move on. It'll be on the YouTube if you didn't catch it all. So, all right, so on the graph now. Let me see, what do we have? We have negative 3 is an x-intercept. So at negative 3, an x-intercept. So 1, 2, 3 right there at negative 3. And then at 9, 9 is a vertical asymptote, and so is 1/9. 9 and 1/9 are vertical asymptotes because they came out of the denominator equaling 0, didn't they?
Yeah.
So at 1/9, where's 1/9? That's really close,
Really close to 0.
right here, but just a little bit to the right. That's 1/9, and then way over here at 9. Oh, whoops, a vertical, not an x-intercept.
Nothing is the scale.
Yeah. There we go. So we have 4 sections. You know, section 1, section 2, section 3, section 4, huh? 4 sections. We've got to plug in a point in every section to find out if the graph is positive or negative, above or below. It's a little messy. So be careful. And all you care about is the sign. So I'm going to plug a number in the left section, like, how about negative 4?
Yeah.
And a number in this section, like negative 2. Or yeah, 0. I could do 0, huh? Yeah, good idea. Let's just do 0.
And then 5, and then 10.
And then here you could do like 1, which is nice. Or you could do 8 or whatever, and over here you could do 10. Just a number in each section. Doesn't matter as long as it's in the section. So let's plug in. Plug in x is minus 4. So to what? What's my function? Where was it? Right here. To this one right before the end of step 1, when you had the 0, and you had it one fraction. That'll be the easiest. So y equals 20x plus 60. So this is what I'm going to keep plugging into. Let me just write it up here. Y equals 20x plus 60 over x minus 9, 9x minus 1. So that's what I'm going to plug into again and again and again. So plug in negative 4, get 20, y equals 20 times minus 4 plus 60 over minus 4 minus 9. 9 times minus 4 plus 1. So all I care about there is positive or negative. So the top, yeah, this will be negative 80 plus 60. It's going to be negative on the top. Negative 4 minus 9, that's negative. And this is negative 36 plus 1, it's negative. So it's 3 negatives,
Which is a negative.
which is negative. Is that good? 3 negatives
Odd number of negatives.
is negative. Right? If you have 2 negatives, that's positive. You have 3 negatives. Doesn't matter where they are, top, bottom, whatever. If you have 2 negatives, it's positive. If you have 3 negatives, it's negative, huh? So that's down. Now how about the middle? I'm going to plug in.
0.
Plug in over here. I'm going to go down here.
There's 4 sections.
Plug in. Yeah, I'm going to plug in 0. You can plug in -1, -2. I'm going to plug in 0. So to this function up there, so y equals 20 times 0 plus 60 over 0 minus 9, 9 times 0 minus 1. So that's going to be positive on the top, negative here, and positive there. Wait, did I get that right?
You said -1.
It was just
It's-
by
it's-
the asymptote.
Oh, I hit the asymptote. It's just such a mess. So that's negative right there.
Yeah. So I am smart.
Negative. So 2 negatives? Positive. So it's up here. Is that good? It's really easy to make a small mistake. You saw me start to do it right there. What saved me is I doubted that it was going to be negative again. I thought, no, I knew that wasn't a bounce point. Because the power on that guy, on the -3, which came out of the numerator, is just a 1 power. The -3 goes right there. I knew it was a pass-through. So other information can help you catch small mistakes. I knew it had to pass through and go up. So, all right, so let's plug in 1. Right, I'm over here, plugging in 1. This problem keeps going on and on. Plug in x is 1. 20 times 1 plus 60y equals over 1 minus 9. 9 times 1 minus 1. So what is that? Positive over negative times positive. It's negative. So that's what I thought. There it is. It's down there. It's negative. Going down both vertical asymptote lines. Finally, over here on the right, plug in x is 10 to the same function. Whoa. I'm getting weary of this problem. Y equals, plug in 10. 20 times 10 plus 60 over 10 minus 9. 9 times 10 minus 1. What is that? Positive over positive times positive. Positive. Everything's positive. So the graph is up here.
But it can't cross the asymptotes.
Okay, so with all that said and done,
But it can cross the
3.
what's going to happen? Where is this function? What do they want from? What do they even want?
We don't have a horizontal asymptote.
I don't even remember. What do they want? Less than 0. There it is, less than 0. So they want to know, where is that thing less than 0?
Over there.
Over where? Here
That one place. Yeah.
and here. Right? Those two sections, the graph is less than 0. It's below. So how do we say that answer? So that's from negative infinity to 1/9. Do you see that? No. Negative 3.
Yeah.
It's testing you. Good.
That's what I said.
Negative 3. United with 1/9 to 9. Sorry, I'm getting a little scribbly there. Can you see that yellow color? So negative infinity to negative 3 and 1/9 to 9, huh? That's the answer to that one. All right, I'm going to look briefly at a couple others with our last 5 minutes. That's the worst of it right there. Questions on that? Is that okay? YouTube. Basically says, for what positive numbers, I don't like that color there. So, for what positive numbers will 3 times the cube of a number, 3 times x cubed,
Yeah.
exceed, greater than,
Oh, yeah.
12 times its square, 12 times its square. There's the equation, solve it. Good? Number 21, domain. What did we learn about domain? Why are they asking domain all of a sudden? Well, about domain, what did we learn about domain? 2 trouble areas. Denominators can't be 0. And inside of a square root
Not be 0.
must be not negative, meaning greater than or equal to 0. Remember that? Remember the inside of a square root can't be negative. Square root negative is imaginary. Right? So the inside of square roots cannot be negative. What's not negative? Greater than or equal to 0. Solve it. Is that good? Remember the inside of a root can't be negative for domain? All right. So they're given different ways they're going to become greater than, less than problems. You see how they're doing it? 25 has a lot of words. Suppose the daily cost C of manufacturing X bicycles is given by blah, blah, blah. Now blah, 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 blah. Look right here.
This problem is kind of difficult.
What's that?
I said I pay attention to this problem instead of hacking away.
25 and 26? 25 won't be hard. 26, I'm going to skip. Because it is hard. If they get too hard, I just skip them. All right. Average cost. Average cost. Here's all you need. This sentence has it all. Average cost. What's average cost?
It has
Daily average cost. Boom.
less than or equal to.
So average cost, which means that function, they just said that function is average cost. So that function, right? See what it says up there? Average daily cost given by this function. So average cost, that function, to be no more than, not more than, not greater. What's not? What if I say it's not greater, it's not more?
Less than or equal.
Less than or equal, right? That's not more. Not more than 110. Right? Bring that 110 over, get a common denominator, blah, 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 blah. Does that make sense how I set that up? That good? So there it is. Take it from there.